All right, the last example that we're going to do is the nitrate ion. All right, that's our NO3 minus ion. Nitrogen is group 5A, so we have 5 valence electrons. We have 3 oxygens, each having 6 valence electrons, and we're going to add 1 electron from the negative charge here. All right, so that's going to be 5 plus 18, 23, 24 valence electrons, and so that means we're going to have 12 pairs of electrons. All right, keeping with our theme of the nitrogen only being 1, so that's going to be our central atom. We're going to put some oxygens around the outside. Then we're going to start adding in our 12 pairs of valence electrons. So typically what we do is start filling around the central atom. So 1, 2 pairs, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then 12. All right. And so typically, like from here, we can start checking from octets. I think what you'll see around the this oxygen on the left kind of stands out that it doesn't have an octet. Something that I didn't mention before, when you're drawing your Lewis dot structures and deciding like who gets the electrons, typically I start around the central atom and put all my electrons there. But something that you'll want to know about Lewis dot structures, and this will come into play when we talk about resonance, and when we also talk about formal charge, is that typically, you would assign and give electrons to the more electronegative element. So what I'm actually going to do is I'm going to move these electrons that are on top of the nitrogen over to the oxygen on the left. And so that would probably be something I would do because oxygen is more electronegative. It's further to the right on our periodic table. So with that in mind, we can start looking at octets. And I think what we can probably see is that around the oxygens, we have octets, but around the central atom, we don't. So we're not quite where we need to be in terms of our octets. So what we can do is think about how do we move some electrons around so that we maintain our octets around the oxygens, but also make an octet around the central atom. And so what we need to do is create more shared pairs. So I could take, for instance, this top pair of electrons, and then I could move them to the center. And if I move them and make them a bonding pair, then we'll maintain our octet on the oxygen on the left, and then also have an octet around the nitrogen now. So what that would turn out to look like then would be, here's our nitrogen, and then our oxygens again. Move that over a little bit. And then we would have our double bond here on the left, and we're going to write in our other electrons that we had before, and then the other electrons stay where they were originally. So the way that I would write this then, so we have an octet around everything now. So we have an octet here, octet around our central atom now, and then octets around the other oxygens. And you wouldn't be circling these for your final answer. I'm just sort of verifying we do have an octet. When I write my Lewis dot structure for the nitrate ion, I would make lines for our bonding pairs. So we have 2 bonding pairs here, and then we have single bonds here and a single bond here. So the way I would write this would be that I would write N, and then here's our bond situation. So our bonding pairs are the lines, and then I would have my lone pairs or my unbonding pairs of electrons on the outside. And this is how I would draw my Lewis dot structure. All right. For these oxygens that are on the oxygen on the left, it doesn't matter if you draw them in different places, you know, one on top, one on the bottom, or any kind of variation. That's kind of how they would look. Now, in terms of just where you would draw this, which you may have said, well, why didn't we move some of the electrons from this oxygen on the right or this oxygen on the bottom? Couldn't we have taken, you know, one of these pairs of electrons and made them a double bond, and still have the same sort of structure, and that would be the case as well. And so we could actually draw this, you know, our double bond in our picture. Our double bond in our picture could have actually been either here or it could have been here. And that idea is resonance, which we'll cover maybe in a different video. But this is how you would draw your Lewis dot structure. The only thing that I've left out until now is this idea that you would draw a bracket around this, and then you would write